welcome to Motion That Matters. Look, there's motion. What is this? Play around here with these two magnets. Oh, there's three. Excuse me. Any child could tell you what this is, right? We've got magnets here. And the root of the word magnet is M-A-G. That's the same as magi and magic. But everybody knows what this is, right? Do they? Let's see. Keep this one set aside. All right. Oops. Hello. Sit up straight and tall. A little prep here. End stream. No, end stream. Ooh, hard that does not sound good. Oh no. I think my computer's dying. The title said can they possibly read that? Magnetic ring theory with momentary monopole moments. Maybe this one won't go public. Back to those magnets. Might take some editing here. Okay. Something as simple as magnets. We all know about what a magnet is, right? Difficult getting motivated here. Probably have to start and try again. Or maybe I can edit this. Magnets. A magnet. We could put it over here. I don't think you can see that far away. Let's fix that right now. Now you can probably see. It's actually a little mini of a. There's a Venus and there's Earth. That's an actual little. That would be a depiction. That would be. A depiction of what is known as a. Can I get this in my hands just right? Sorry. A depiction of a magnetic field, what is known as a static magnetic field. All right, let's just say that yellow dot was our magnet. Say that was the Earth. So these things. The same with this magnet. Everything extending outside the physical matter. Physical meaning the structure of this material. These extend outside of it. Science knows all about them. That's what the suits tell us. They don't talk about them too much, but here we have it. We have these structures that extend outside of matter. What are they? What exactly are they? Well, that's a simple. It's magnetic energy. There's no mystery here. You know exactly what they are. And that's what you've been told, and that's what you've been led to believe. And so that should be the end of the story, right? Well, that's only the beginning of the story. What are they? Too many. Only the beginning of the story. What are they? Too many wires here for my slide to work. What are they? Are they matter? I heard that physicists would say no. Are they antimatter? I'd say no, none of them are magnetic energy. That's all they are. Is it the path? Is it the path of a electron? Are these electron paths? Are the electrons flying around in here and leaving these trails? No, there's no electrons there. It's just magnetic energy. Now, don't ask any more questions they don't want to answer because they don't know. That's simple. One of the simplest things a child could see it. All right? Magnetic energy. They don't know what it is. That's magic. They have a lot of magic in their science. When they don't want to talk about it, they don't. So they're everywhere. Just breathed in a bunch. It's in everything. Every piece of matter. The tiniest piece of matter to the largest galactic structure. Matter, anywhere there's matter, there's magnets. So that led me on a pursuit many years ago, and I started doing research. And where do we first detect these? In the subatomic particle. And obviously they're there. Electrons, magnetic fields, motion, orbitals, a whole bunch of stuff you're probably really not, many of you aren't interested in at all. It's like, but it's a proof that what we're being told and led to believe is that they've got all this stuff figured out. It's nonsense. They do not. And nearly, a full decade ago, I put my mind to it. Came up with some of this. Came up with magnetic ring theory. Momentary monopole moments, or MRT, M3 meaning 3 M's, momentary monopole moments. What are momentary monopole moments? Well, in the magnet here, we have a north and a south pole, an attractive and a repulsive side. And the naming convention that these scientists use is always interesting. Don't know why they didn't call it attractive and anti-attractive, as they would call matter and antimatter. That in physics, there's this missing piece that Big Bangers say that at the moment of the creation, all this antimatter was created because it's the only mathematical thing that they can figure out. Well, they need to go back to square one. Their failure is obvious. That unless there's an anti-universe out there, which could be possible, but there might be better explanation that every piece of matter, just like this magnet has a north and south pole, every piece of matter could have the antimatter built right into the matter. That there could be a motion that could create that. So let's go back to momentary monopole moments. So if I could take this magnet and just break it in half, pretty tough. Can't do it. And I could take the North Pole in one hand. Well, say this. The North Pole in one hand and the South Pole in the other hand. We might have an explanation for gravity. Being a very attractive explanation for gravity. As it would only attract. That could be an explanation for gravity. But if that were the case, it's attracted downward, isn't it? If that were the case, when these planets here were in motion, and there was only an attractive force, pretty soon they'd end up in the center. The two would come together. So what do we need? We need a force that not only attracts but also repulses. Seems like we've seen that somewhere, haven't we? So in physics there is no monopoles. They don't exist. And I don't claim that they do. I claim that they're momentary monopoles. That they only have momentary monopole properties. There's only one kind of magnetism. There can be many, many different varieties of how they're structured, but attraction, repulsion. Momentary monopole moments. Moments meaning a time frame. So if everything is specifically timed, if we had, make this again good. If we had a Lionel train set up to go around a circuit here, we had another one over here going down the circuit here, and we had magnets on our little Lionel train set. We had the magnets set up that every time they came by, they could attract one time. And the next time they came around at a different timing, they could repulse. So that if you set up a specific timing in this magnetic energy, you could have an attractive or a repulsive. And that all of that's been worked out. In other words, if you had that worked out specifically, you could have anti-gravity. If gravity is actually a magnetic property, right? So it's not where I started. I started at a more fundamental, lower level. I was trying to figure out how electrons could be jumping from one energy level, or we used to call them energy shells, to another. And that curiosity started in the 19th century. The first theory was called plum pudding. Sounds very English, probably because it was found in England. And that was that the electrons were set up in matter like plum pudding. You jump the raisins into the plum pudding and you mixed it up, and wherever they scattered, that's where they ended up. So, see if anybody's joined me. Nope. So, where are we at? Electrons, how they can jump. So, a little background as we go. Kind of a glare on that, isn't there? That's kind of not good. Not much better. Still not good. Done. I think anybody can make that out. Sorry. Might be a little better. Just got the wrong kind of light here or what? I think I'll need to do some editing here. Climbing on this thing. Here we have a structure. This is called the vesica piscis. A circle, set the compass, draw another circle, the vesica piscis. Latin, fish bladder. Imagine that. What is a fish bladder? It's an organ in a fish that can be altered in size by putting more or less air in it. The fish can maintain neutral buoyancy. In other words, like a specific gravity. Isn't that interesting? How did that happen? So this is these are magnetic rings. These are my version of magnetic rings. Just like we were looking here, that there's these magnetic rings. Right? These magnetic rings. We're talking about the lowest level here. We're talking about hydrogen. And yes. I'm suggesting that it's all about magnetism. That these rings are not what they call a static field. In other words, they're stuck like this always. I'm saying these rings are in motion. In the Rutherford model, the standard model for the subatomic particle, they talk about these orbitals being like planets, that the electrons are going around the nucleus, and that there are protons and neutrons in there at the center in the nucleus, and they have a mass, and these electrons are twirling around it. But they don't just twirl around like this. Okay, they have different orbital classes, and it escapes me how they distinguish them. S, K, P. I don't recall the specific characters in the alphabet that they used to talk about these different. This would be the most common one, hydrogen, and then this, nothing past 90 degrees, nothing 90 degrees, a portion of it. So I've never seen planets jump around like that at angles like this. So, and then they also claim that there's a charge on the electron, this particle, a piece of matter. They're talking about smaller and smaller and smaller particles. That as this electron goes around the nucleus, it's creating the magnetic field because it's a charged particle. That's how magnetic fields are created. Now, that's a theory. I disagree. I think the magnetism first, and that the electron is a product of the magnetism. And we'll show you a little bit about how this three-dimensional motion of ring flow, ring rotation, and orbital works. So, first, there's an axis here. We'll start backwards. So, you can envision these two rings. They're turning like this. They're turning around in a circle. They're orbiting. They're orbiting. We wanted to put, if this is hydrogen, we wanted to say that there was one electron. There it is. It would be going around, going around, going around. So that's the orbital. Now, there's also known in magnetism that there's a flow. You look at depictions of the Earth, they talk about this flow inward like this. Outward, inward, outward, inward. And then ironically, they have a thing called a mirror point. A mirror point. That if this was the Earth and this was its magnetic field, that there was this flow. And then there's this mirror point. This area here they would call a block wall. That's where so now I've added South Pole magnetism, North Pole magnetism. The compass, if this is the Earth, the compass always points north. So north and south attract. So the South Pole energy is up here. Compass always points north. But for some reason, as it is a north polarity here, when it gets to here, somehow it flips to south. Now, how can that be? There's just like a wall there, a line in the sand. This is the equator. There's a point out here that's magically south upwards and north downwards. So how can there be a flow like this? And then there's this magic point here, that this mirror point. I am assuming that they're suggesting that, again, magic, that there's a flow, but then there's this mirror point, that somehow this north energy, when it gets to here, it flips and turns to south because the compass always points. There's a line. So anyhow, more questions. Okay, so that would be one of the three motions. That would be orbit. And next we have ring flow. Now we'll do the ring rotation next. So I'm adding another axis to the diagram here. And in advance, I put an orientation correction. So this is depicting that if you could imagine these rings, the magnetic rings, and they can turn like this. and collide with each other. That would be the second motion, ring rotation. And then we've already talked a little bit about ring flow, that there is a flow to these. So I'm saying that this and this and this is all a one-for-one motion, that as this makes one full turn, the whole structure orbits in one full turn, and that the rings, these rings, flow in one full turn. So the way they're at right now, this red highlighted area would represent South Pole energy. And that this lower area here would represent North Pole energy. And then we put it all into motion at 90 degrees. This structure would look like the rings would be turned this way. They would look just like that. Now, with the flow of these would no longer be up. They would be something like, to think about this now, they would be turned 90 degrees. So we'd have something like cut. Stumped myself. Been a while since I've walked through this. I've stumped myself. Hmm.